Hey everybody, welcome to Supercoding Fun Time with me, Eugene. I am Eugene. Since this is the first time I'm doing this stream, I'll tell you a little bit about myself. I'm an associate professor in the Department of Chemistry and Biochemistry at Florida State University. I'm a quantum chemist by training, which means I'm a theorist, and I develop computer programs to try to model the behavior of electrons in molecules and materials. So I really like programming, which is why I got into the job that I have. And this is an effort that has basically there's two reasons I'm doing this. One is I want to relive some of the fun projects that I did when I was a graduate student, where I would code random projects that were related to something that I wanted to learn, like OpenGL, which is one thing that we're going to talk about tonight. But then another reason is I have a whole bunch of tutorials for my graduate students and anyone else who's interested in them in the chemistry community on my website, and I kind of want to spruce them up with a more interactive type environment. So over the course of however many streams I do here, I'm going to do a mix of fun programming projects like what we're going to do tonight, and also some programming projects that are more closely related to quantum chemistry. You're more than welcome to drop questions or comments in the chat. That'll make it more fun for me, at least, because I'll realize that someone's actually here watching, which would be nice. Okay, anyway, let's get going. Today I want to do a super simple OpenGL tutorial, which is a visualization library, in order to render some... Hey, Rain Lee 323, thanks for stopping by. We're going to use OpenGL to render a whole bunch of birds, in quotation marks, which are just going to be little black squares, and I'm going to try to get them to flock. So we're going to use really basic physics and encode in the physics enough information to try to get these birds to have some interesting behavior. Okay, so let's start. I think you can see my terminal, so I'm going to go into the directory I'm going to use. There's a bunch of stuff here you don't need to see. I don't know why I just did ls. These projects I'm going to have here are going to live in GitHub, so I'm going to go ahead and clone the repository I'm going to use there, where I have at least that's not how that works. I have at least some dummy placeholders for some of this code. Not very much. At least the make file, because I'm terrible at writing make files. Get these birds to have some interesting behavior. Okay, so this is a public repository, so as this channel matures, there'll be more projects in here. There's literally nothing there now except for the birds one that we're going to do. I don't know what's taking so long, because there's nothing in the repository. Maybe it's because I'm streaming, my internet's really slow. I don't know. Well, I thought I could be done with this project in 3 hours. Maybe it's going to take a little bit longer than that. Enter, enter, enter. All right. Okay. So here we go. So this is a public repository. Supercoding Fun Time. All that's there is my birds. First up, I'll open a makefile so you can see what kind of libraries you need to include to do what we're going to do here. Basically, you need OpenGL libraries that are libgl, libglu. I should have put together some instructions for installing these, but just Google OpenGL, and you can use, if this is Ubuntu, you can use sudo apt-get to install all the libraries you need. And then I'm going to have a main function in a main.cpp, and I'm going to have a class for my birds that's going to live in birds.cpp. Okay, first up is main. There's nothing here yet. So I'm going to open another window so I can actually compile. I'm going to put the compile window under my face, because we don't need to see that, and the main one up here. And I'm going to start adding appropriate code. So first of all, there's some headers that you need to include to use OpenGL. And here we go. So before I edit the main function, I'm going to add a couple of functions that OpenGL is going to use to render whatever images we have. First, there's going to be a display function, which I'll call display, because I'm not at all original. And it's a void, and it takes a void as an argument. And I should point out while I'm doing this, my understanding of OpenGL is extremely rudimentary. I kind of undertook this project, very similar to this as a graduate student, to learn basic graphics rendering and then also just to have some fun with a flock of birds. So the first thing I'll do in my display function is clear the background. I'm going to use this macro GL color functions that OpenGL is going to use to render whatever images we have. Buffer bit. Don't ask me what that means. I just know I need it. And that's all my display function is going to do for now. It doesn't do anything. It just clears the screen. Next up, I need an idle function, which I'll call idle. The point of the idle function is once the display function runs, it's over. So if you want your code to take some input from a keyboard or something like that, you need to keep calling the display function while you're waiting for those inputs. And the idle function is basically in charge of recalling your display function over and over again. So the idle just consists of a function to post. I'm going to use it's called glute post redisplay display, and I call GL flush that will flush all the appropriate buffers. Okay, at this point, I want to make sure that this code even compiles because who knows if it will. So I will make. All right, success. It's not going to do anything. Okay, not surprising. Which I'll call idle. Okay. If you want your code to take some. In my main loop, calling the display function while you're waiting for those inputs. I need a lot of stuff. So the first thing I'm going to do is initialize OpenGL library with a glute init call, which takes the arguments we've passed in. Why can't I type the ampersand? And then I will initialize the display with a bunch of stuff that I have over to the side as a cheat sheet. So the first thing in the display mode, it says glute double, which means I'm using a double buffer, which helps helps prevent lagging in your image. You could do glute single instead and see what the difference is. I need a lot of stuff. I actually don't know what these other things do, but it doesn't matter. Next up, I need to pick my window size, which I'm just picking based on the machine I'm using. I practiced beforehand to make sure I got something that looked good with Twitch and OBS. I need to put my window in a specific position. Initialize the display as a cheat sheet. Init window size. I forgot an init. And I'm going to put that again at a position that I chose based on how it would look here. And then I'll create my window. Helps prevent with some name. I'll call it birds. Birds. And let's see. Is this going to compile? It didn't. Glute create window. What's wrong with that? Next up, I need to pick my glute create window. The machine I'm using, I practiced beforehand. Did I mean glute create window? Yes, I did. I forgot my E. The chat is a perfect place to tell me all the mistakes I'm making. I need to put my window in a specific position. Okay, so did you see that? There goes my window, and then it goes away because nothing happens in my display function. Actually, I didn't even call the display function, so it just created the window and then the code ended. Okay, so the next thing I need to do is initialize some viewing values. The details here don't matter. You could just steal these if you wanted to do some simple OpenGL programming yourself. So first I'm going to pick a background color. Window. What's wrong with that? Create window. And I'm going to set it to be white. So that's called the clear color. These are RGB values. They go between 0 and 1. So 1, 1, 1 is white. And then I'm not sure I don't remember what the fourth one means. Doesn't matter. 1, 1, 1 is white. There goes my window, and then it goes away because nothing happens in my display function. I'll initialize some other viewing values. Initialize some viewing values. Okay, and now I'm ready to actually call my display function. And I'm set to be white. So So this defines, I'm sorry, this defines my display function.
There are RGB values.
I mean, defines
0 and 1, so 1
my display function as display.
And then I'm not sure what
The fourth value in the background color is the alpha channel for transparency. Thanks, Blue Density. That's very helpful.
doesn't matter. One is white.
Now I lost my place. Okay, I defined my display function. I also need to define my idle function. And then I call OpenGL to do its thing.
My display function.
Okay. It compiled. And
defines.
there's my birds window. It doesn't do anything because I didn't actually plot. I didn't actually render anything.
For transparency. Thanks, Blue
Okay,
Density.
super.
That's very helpful.
So now let's put something in the display function and see what happens.
Now I lost my place. Okay, I define
Okay, I'm going to pick a color.
my idle function. Basically, I call OpenGL to do its thing.
And I'm going to draw a polygon.
Okay. It compiled. And
Which is encapsulated in this GL begin, GL end.
I didn't actually render.
The polygon has 3 vertices.
In the display function.
So I'm going to define my, 4 vertices. I'm going to do a square.
Color. Idle function.
And we're just going to try 1, 1, 1, 0. We're just going to see what happens here.
A polygon. Okay.
Nothing happened. Why is my background not white?
What
have I done wrong?
The polygon has 3 vertices.
Well, I should have practiced more.
So I'm going to define my, 4 vertices. I'm going to do a square.
And my computer's about to freeze. I think it
And we're
froze.
just gonna
That's
try-
awesome.
1, 1, 0. We're just going to see what happens here.
Alright, so I just closed Twitch on that computer, so it might be harder for me to check the chat. Because I'm going to have to use a different computer. Okay, well, I'm waiting for that. I need to figure out why this didn't work. I have an idea. Maybe I need a flush and a swap buffer. There we go. Beautiful. And now I have Twitch open here. So hopefully I can get my chat back. Okay, I'm back. I'm back. Okay, so here I have a square. I made a square that's black on my white background. How exciting. Actually, I think I left out one important piece. I didn't specify the dimensions of my box in my main loop. And I should do that before I call the display functions, I guess. So I should have GL ortho. So in the X, Y, and Z directions, my box is -1 to 1 here. And let's just make sure that's still correct. Okay, so that looks right. Let's make the x dimension a little bit bigger and make sure we understand what that parameter actually means. Okay, perfect. So I've got my box, and I can draw a square in it. We should call it a night. Okay. Now, I know how to draw something in a box. I want to start defining my birds so that I can draw my birds in my box instead of just this boring thing. And because this display function lives outside my main loop, I need to define my bird class as a global variable. I don't know a better way to do this, but this works. I don't like global variables, but I think that's what I have to do. So I'm going to call this, I'm going to use a standard shared pointer to what I'll call the flocking birds class, which we haven't defined yet. I'll call it birds. And then in my main loop, I'll create a new birds class. Well, let's forget this. Let's actually make the birds class first. So I have a header for my birds class. It's birds.hpp. I have a header guard here, the usual C++ stuff. And we need to think about what sorts of parameters need to be included in a header to define a class for a bunch of birds that can flock. So I'll start just by saying class flocking birds. I'll define some public functions that are accessible from inside the main loop, and I'll define some private parameters and functions that are only accessible within the class. The constructor should be public. And I'm going to have some input parameters into the constructor, the number of birds, and also the size of the box. Because the size of the box will determine how close together my birds are, and what I need to think about what kind of velocities the birds should have, and that depends on the box size. So everything I've done here, I've kind of optimized for a specific box size and a very specific set of parameters. And one cool thing I'll show you is that if you change any of these parameters very slightly, once you have your flock going, it changes the behavior completely. It's very sensitive to parameters. It's kind of interesting in that way. I need a destructor, which won't take any parameters. I'm going to have a function to update the position of all of my birds in my flock. Basically, this is the function that will get called every single time the display function gets called. And then I need to know the box size outside of this class so that the viewing box can be consistent with that. Anybody who makes it through this whole thing with me, I will buy you a beer the next time you're in Tallahassee after COVID. Okay. Private parameters. I don't think I need any yet. Let's go put our birds in the make file. Let's put what we need to define the box. My box size function has a space in it. Thank you. Space underscore. The compiler should figure it out. Okay, so like I said, I don't know a better way than to have a global instance of this class, or the pointer to the class. So there it is. It's a standard shared pointer, blah, blah, blah. And now inside the main loop, I guess it doesn't really matter where. I'll have it be the first thing that happens. I need to call the constructor for this guy. And I want to use 1,000 birds. It's a big flock and a box size of 10.0. 10 units, whatever my units are. 10 Eugene units. And then I need to make sure that the box and my viewing values are consistent with one another, and I have found that going from just below 0 in terms of the box size, a tenth of the box on the left, and 1.1 times the box to the right, that works pretty well. And then in the Z direction, I do something a little bit different because you get some weird clipping sometimes if you don't have enough space in the Z direction. This won't compile because I don't think I included the birds header. And now hopefully this will compile. Make behind my head. Return box size. Box size is not an actual parameter. You can't see the error, it's behind my head, but it's because I had that box function return box size, but I hadn't defined box size yet, and now I probably need to define these functions inside the birds.cpp as well. So here I have included birds.h. I already had this file here, there's nothing in it. I include birds.h. I need to call the constructor is the first thing. Let me pull up my cheat sheet. Yeah, perfect. I need to call the constructor, or I need to define the constructor. And in here, I need to define my box size, and I need to define n as the number of birds. So that's another class member that I hadn't added yet. So we'll go back to the header. I don't think I need to worry about long ints for my number of birds, so an int is just fine. I need my destructor, which is empty, but I still want to look at it anyway with my cheat sheet. And that should be that. Now, I guess I can go ahead and define that update flock function. It doesn't do anything. I think that's the only function I had in there. Box is not defined. So box was the box size that I need to grab from my birds class. And hopefully this will compile now. Okay, look, I still drew a square because I left that in the display function, but now the box is much bigger. It's 10 by 10 instead of 1 by 1. Okay, cool. This is going swimmingly. Okay, now to define the birds that are going to fly around, I need containers for all their positions and for their velocities and for their accelerations. So I need to add all of those to the header, the birds header, and I need to add, I need to initialize them to some specific values, and then I will eventually need a function to actually plot the positions of these things. So in private, I'll add positions. I'll add velocities. And I'll add accelerations. You know, because we're going to be solving Newton's equations, F is ma, basically. Well, sort of. And I actually need to save a copy of the accelerations because of the way that velocity of relay is defined. Okay. Let's make sure this compiles. It should, because I didn't do anything important. Okay, so I have all of these containers. They're all double stars. And now I should go over to the actual C file and allocate memory for each of these pieces. So I can do that in the constructor because now I know my number of birds. I write in a weird combination of C and C++, so I insist on using malloc. So I have XYZ, my velocities, my accelerations, and my saved accelerations, which are A, X, A, Y, A, Z, save. No time to make this pretty. Okay, we can make it pretty. There's always time to make things pretty. Otherwise we get headaches. Okay. I should also memset all of these guys to 0. Oh, I forgot my 0, didn't I? Let's make sure I didn't mess anything up. Super. It's a square. How about that? That's amazing. Okay, I need initial values for all my positions and velocities. I don't need initial values for my accelerations because we'll determine those. Double semicolon. So I'm going to use random positions, so I need to seed a random number generator. I'm going to use time as the seed for the random number generator, so we get different results every time this runs. And then the X position will be casting double as a casting rand as a double divided by rand max. So that'll give me a number between 0 and 1. Now that gives me a number between -0.5 and 0.5. And now that'll give me, that's not what I want. That's how I want to do the velocities. I just need double. So this will give me, this piece gives me a number between 0 and 1. This gives me the box size, so it's inside the box. X, Y, and Z are all random, and I can initialize the velocity as well as random numbers. And here, I'll define this in a similar way, but I want a random number between some small plus and some small positive and negative numbers, because I don't want my birds flying around like crazy. So that'll give me a number between 0 and 0.5 and -0.5. So that's now between -1 and 1, and then times a small number that I played around with to get the right value. Okay, I should have initial velocities and positions. And now, I guess the right thing to do is to plot them. So that would be in the function that I called update flock. I mean to say render them. And actually, inside this function, have you done anything to give back on Black History Month? Not yet. Everybody should read about Black History Month. I need to print. That's going to be a function that I'll define. And that's where all the printing, rendering the images will occur. So that needs to be a private function as well. Okay, in print, I basically need to go over every single position of the particle and draw a square. I need to go over every single particle's position. And yeah, okay. I need to go over every single particle's position and let's define a color for the particles. Sorry, I'm a quantum chemist. Define a position for the color for the birds. So I'm going to pick black for now because I'm not at all clever. And then I'm going to draw a polygon for each of these, which I will spare everyone watching me do that. I'll just copy the polygon I had here, and that shouldn't be two ends there. So you don't have to watch me make another square. And obviously this would just draw 1,000 squares in the same exact spot, so I need to mess with the actual x and y values. Okay, now I need to decide how big my square should be. So I can just pick some small number that I'll call min for a reason that will become clear later. This looks crazy. It's because I picked this size by trial and error as to what would be a good size. And then I need to define the squares appropriately. Okay. Who wants to bet this isn't going to work? Beautiful. Why did I call it R? Sorry, I gotta make it pretty, otherwise I can't think. Why is Z not known? X was not declared in this scope. Oh! Why didn't anybody tell me that I didn't make these member functions? Because no one's paying attention. Beautiful. Told you it wouldn't work. I think I need to add a flush. Oh, you know why? Because this function isn't even being called. So of course it's not going to work. Okay, so this is going to replace that square that I had in the main loop. So instead of doing that, I'm going to call birds update flock. And now we should get a whole bunch of random squares on the screen. All right. Isn't that beautiful? I think it's beautiful. There are my birds. They're not doing anything. Okay, now there's a z dimension that we don't see because we're looking straight on it. So it would be nice if the bird size reflected how close they were to me. So I can scale that square by a value that's related to the z position, and then the square sizes will change depending on what the z value is. So that's why I used the parameter min, because that's going to be the smallest value of the size of the square. And now I'll define the length of the square as 0.02 times the box size. Oh, sorry. I'll define the size as 0.08 times the box size, and again I picked these parameters because I played around with them a lot. Divided by 10.0. Is size even? Yes, okay. And then inside, these two parameters will determine how big my squares are. And inside here I need to define an R value or a length value for each side of the box that's specific to the bird that I'm talking about. So it's going to be size times z divided by box size plus min. What did Rain say? Is it strange that the birds are far away from the box edges? No, it's not, because I chose my box to be 10% too big on all of the edges so that I could see the edge of the box. I'm going to add periodic conditions eventually, so once the birds hit the edge of the box, then they will just pop out on the other side. Great question. Okay, so now I've defined a size that's scaled by the z value, which is between 0 and box size, and there's a minimum size that's that minimum I chose before. So now I just need to change this plus min to a plus r. And now, hopefully, the birds will all be different sizes. Hey! So the size tells you how far away the bird is from you. It's very small. I can't see it. It's far away. How about that? Okay. Up next, we've got random positions. We've got random velocities. We've scaled the size of the bird by its position in the box. Now we need to do a velocity. We need to actually let the birds move according to their velocities. So I think what am I going to call this function? It's just in update flock. So in update flock, the first thing I'll do is update all of my positions, and then I'll print the new positions. So everything I do has to go before this. So the velocity relay algorithm, I'll tell you, so it's clear what I'm doing. Given an x value at a given time, you can predict x at the next time as the original x position plus the velocity times the time step that you're going to take that we haven't discussed yet. So I'm basically integrating Newton's equations in time. So I need a time step to take. My chat. Where'd my chat go? Sorry, blue density. Maybe we want to do this later, but I haven't freed any memory in the destructor. That is true. I'll do that when we're all done. I should do it now. You're right. Good coding practice. So I think this is all that I've mallocked. So because I'm using a shared pointer, standard shared pointer, the destructor will get called automatically whenever this class goes out of scope, and then you'll want to free your memory at that point, so you don't have a memory leak. World record speed. Okay, so my velocity relay, back to that. I have my x positions updated in terms of the velocity and the time step, and also there's a dependence on the acceleration and the change in the acceleration and the time step squared. And you can also update the velocity in a very similar way as this should be at the time t. The velocity at time t plus the acceleration averaged over the this is a leapfrogging technique, so you update the position, and then the new position gives you information about updating the velocity as well. So I have my acceleration at the old time. Hey everybody! Adeline wants to say goodnight. That's you, do you see?
Yeah.
Can you say goodnight, everybody?
Good night, everybody.
Enjoy the birds, everybody.
Join the birds, everybody.
Beautiful. I love you. Good night.
Love you.
All right, come on.
Is that
I'll see you in the morning.
was at work with you?
You were at work with me. Thank you for coming.
Come on. Come on.
Bye, sweetie. Oh, everybody said good night. How kind. Okay, what was I saying? Yeah, so the velocity is actually updated according to two different accelerations. So you have acceleration at time t plus dt. And I think I need to multiply this by dt to get the right units, and also I need a factor of a half to account for the fact that I'm averaging here. This is kind of silly that I'm taking the time to do this in the correct way, because the accelerations I'm going to do are basically made up. I'm going to define really simple rules to make the squares have the behavior that I want them to have. But anyway, if you were to do a real velocity of relay, you would determine the accelerations based on the forces that are involved. F is ma. Tells you what the accelerations are. Okay, so that's what we're going to be doing. So that means I need to have both the acceleration at a given time and at another time. That's why I saved the container asave. I could probably do this in a way, I could definitely do this in a way that used less memory, but this was the easiest thing to do, so that's what I'm doing. So yeah, the first thing I'll do is, well, I'll save the velocity. You'll see what I'm going to do. I'm going to define dt squared is equal to my time step times my time step. Oh, we have another parameter that we haven't introduced yet. So dt needs to be the time step I'm going to take. I'm going to add it to my constructor, so it'll get some value whenever the constructor is called. Oops, I don't want to declare it there. And now I also need to add it to the header. Okay, so I'll look for dt squared, easy peasy. So the first piece, I'm going to steal my comment so that I know what I'm doing. The first piece is updating the position. I have to do it for all of my birds. And it's going to look exactly like it looks on the line above. So I append my position in the x direction with the velocity in the x direction times dt plus 0.5 times the acceleration in the x direction times dt2. And then I'll do that in y and z directions as well. And then I'm going to save my, so the position is updated according to the current acceleration. The velocity is the one that's going to need both the current and next acceleration. So I'm going to save each component of the acceleration. And then I'm going to update the velocity in a very similar way. 9yy. So I have vx is updated by adding to it, I should update the acceleration as well. So this is a function that I haven't defined yet. So right now the accelerations are just 0, because I zeroed them in the constructor. Okay, so I want to add to my velocity 1/2 times the average of 1/2 times the sum of the accelerations at those two times. But again, they're going to be the same exact acceleration. They're both going to be 0 because I haven't updated them yet. That'll happen in that function above. And then I don't need to save anything. Boop, boop, boop. And that's all I'm going to do. You ready? So now, if this function's written correctly, my birds should move. But they should all move completely independently based on whatever their current velocity, what their initial velocity is, which was random. And you see, there they go. Isn't that beautiful? They definitely are not flocking. Okay. We can make things a little bit more interesting by adding some kind of, birds are kind of silly. They like to do random things, so I can add a little random nudge every once in a while in my acceleration. So I'll start my update acceleration function just by putting a random acceleration in, okay? So I want to double rand divided by rand max. I should make that a function so I don't have to do this over and over again. Minus 0.5. So that's between -1 and 1. And then in my notes I have, that can't be right. Let's check what I had used. Yeah, okay, between 0 and 1. Easy, that's great, okay. Easy peasy. X, Y, Z. And that should be different for every single bird. Wait, do I have caps lock on? What's happening? There we go. Oh, and you can see my birds have left the box because I don't have any periodic boundary conditions on here. So that's not good. We need to fix that. Okay. I don't have a function update acceleration. So I need to add that to my header. Oh, come on. Anybody know what the problem was? Z was not declared on line 120. What in the world is that? What did I do? Something bad. Something very, very bad. Oh, that must have been when, who knows? Who cares? Okay, so I think I can convince myself that these are not moving in perfectly straight lines anymore, but I'm not actually sure. I guess we could make the nudge enormous and see what happens. Oh, I commented out the update acceleration function. So now that that is uncommented, oh my god, that went bonkers. So that's too big a nudge, guys. I think that's too big. Let's go back to -1 to 1, which is what I had, and they go bonkers. And they all left. Oh no, my birds. So that means I need to have some sort of check to make sure that when the birds leave the box that they come back in. And I can do that whenever I define the I can do it in this update acceleration function because that gets called right after. I should not do it here though. I should do it in the where the position's actually updated. Periodic boundary conditions. That's not what I was thinking. Yeah, okay. So if my position is less than 0, that means I'm outside the box. So I should shift that x value by the box size. Same for y and z. And similarly, if I am on the other side of the box, I should shift in the other direction. And let's see if that fixes our exploding bird flock. All right, so they at least stay on the screen. Now they look like static. That's great, but that's not what we were trying to do. I think that this tells me that these birds are moving too quickly. So I should probably put some limit on their velocity because after all, birds can't fly at the speed of light. So whenever we set the new velocity, we can define a maximum possible value. So I'll use the Euclidean norm of the velocity to do this. So I have vx, vy, vz squared, and I can say if, well, I can say if my total velocity is greater than some maximum value that I have yet to define, then I can scale the velocity so that it has the maximum value. Okay. And now I need to just specify what that max should be. And through trial and error, I found that a good value is 0.5. So let's see what that does. All right, things are great. Everything's periodic. They're wiggling around with some random nudges, and it's periodic, but I still don't have any flocking behavior. That's not surprising because the birds don't see each other, but it still looks cool. So that's great. This is working out. Okay. The next thing I need to do is think about what sorts of parameters could influence the velocity or the acceleration of the birds. So the first thing I'm going to do is note that birds flock, so therefore birds must like each other. So every single bird will look around and see what other birds it sees. And if the birds are close enough to it, because birds don't have perfect eyesight, if the birds are close enough, then it will increment its acceleration so that it moves towards that other bird. So I'm going to do this in the worst possible way. I'm going to do it in an n squared way, which means the cost of this function will increase with the square of the number of birds. You could write it in a way that is linearly scaling, but that's not really necessary for this problem because it's not that expensive. If you had a flock of 10 billion birds, that would actually matter, but it doesn't matter here. Okay, so I have my random nudge that I'll do at the end. So if bird I goes from 0 to n, and bird I will look at all other birds that I'll call j. Before I do this, I want to set my accelerations to 0. Which I do with memset because for some reason I like to use memset. Okay. Now I'm going to decide whether I want to move towards or away from another bird by using the distance between the two birds. So I need to know my x values. So I'll get my position of bird I, and then my position of bird j, and then my distance between these will be xi minus xj, which is actually defined backwards, and it should be, but it's fine, it doesn't matter. What am I doing? Okay. I feel like I must have made a typo, so let's make sure I didn't. Okay, great. So I can't remember how fast these were moving a second ago, but they're probably moving slower because there's a lot of work going on in this function. If I had even more birds, they would be moving even more slowly because it's an n squared function again. Okay, so here we're going to, because I'm using periodic boundary conditions, I'm going to use something called a minimum image convention, which means my bird can see every other bird, and because the system's periodic, if it's over here, if my bird's at the edge of the box and another bird's at the far edge, this bird will see the image of it that's on the other side of the box. So it's only going to see every other bird once, and it's going to pick the closest version of that bird. And to do that, I need to know half the dimension of the box. And since I'm going to evaluate half the dimension of the box 10 billion times, I'm going to evaluate it outside there. It's actually 1,000,000 times, 1,000,000. Okay, so if dx is greater than half box, then I need to shift dx by the box size. So that just means my distance is now, instead of this distance, it's this distance. It's hard to show. Anyway, you have to trust me. That's how this works. Otherwise, if dx is less than negative half box, you guessed it, I'm going to have to shift in the other direction. Okay. I think that's right. I need to do this for the x and I need to do it for the y and z directions as well. I messed something up. God. Getting tired. We're only an hour in though. Okay. Nothing should change in the simulation, just making sure that I don't have a bug. I want to check how far apart my birds are. And then I want to define what if the bird distance is exactly equal to half box. Then it will just, dx won't change. So it'll still be exactly equal to half box. And that's fine. Great question. Man, people pay attention. This is great. Okay. So, no, thank you. The force that I'm trying to add here is a force of attraction. Whenever two birds see each other, they want to go together. But I'm going to assume that there's a maximum distance that they could see each other. That's not the whole size of the box, because that would kind of make the simulation a little wonky looking. So I'll say the maximum distance that a bird could see another one is going to be a quarter of the size of the box. No, whatever. I don't know if your preference is multiplying or dividing. We're going to divide. And then I can say if, I'm actually going to use square root's an expensive function, but I'm going to use it anyway. If r is less than max dist, then I'm going to do something. Blue density. You should declare max dist outside the for loops. Oh, you're right. You know, I think I had it in that spot because I was messing so much with trying to find the right balance of the force applied and the distances, so I had them all right next to each other. But you're right, it should be declared outside the loops. Perfect. Thank you, blue density. Okay. So basically, I'm going to take the simplest possible change to my acceleration. If I'm close enough to a bird to want to be near it, I'm going to increment my acceleration by x, whatever that value is. So really, I just need to figure out like a unit vector for my dx, dy, dz. And I'm going to do it in the following way. So I'm going to define a unit, the x component of this unit vector is going to be dx divided by r. The y component is dy divided by r, and the z component is dz divided by r. And then if I'm close enough, actually I should do that inside the if statement, shouldn't I? Because I might not want to do that work. And at that point, I'm going to update my acceleration with a sign that I figured out by playing with it a lot. That unit vector basically times a number. That, again, this is a number that if you change the number 0.01, the behavior of these birds changes dramatically. So I played around with these numbers a lot. And I think that's it. So now my birds are going to know something about every other bird that's within some distance of them. So that should totally change the behavior of this little flock. Hey, what happened? They all went away. When I and j are equal to each other, r ends up being 0, so I have a divide by r here. So I need to continue when I and j are equal to each other. Okay, so now my birds, it's beautiful. They all want to be near each other. How cute. So they make little bird balls. That's great. And it's fun whenever two bird balls get near each other, they kind of suck together. So maybe that'll happen here. Maybe not. We'll leave it running and see what happens. Okay, this behavior clearly is incorrect. If I want these to look like birds, right? So I think that I need to also reflect the fact that if two birds fly really close to each other, they probably want to move away from each other so they don't crash into each other and die. So I should also have a minimum distance, at which point, instead of an attraction, the birds feel a repulsion. So that's going to go in exactly the same spot. Actually, I'll define min dist outside the loop. And this minimum distance is going to make the birds take on some size. So I want a size that's visually appealing. A size of 1/6 of the size of the box looks pretty good. So min dist is 1/6 of the size of the box. So that means if I'm within 1/4 of the size of the box, I want to be near the bird, unless I'm within 1/6 of the size of the box. Then I want to move away from them. So I'll have else if r is less than min dist. And you know what? I'm going to use exactly the same kind of force as I used for the attraction, just in the opposite direction. So I just changed the sign. And you can change those parameters and it greatly changes what the birds will do. So now they all congregate again. Why didn't this work? Did I not define this correctly? Why did this not work? Oh. That's because the second if statement never gets entered. Okay. Okay, so they still clump up. Aha! And instead of forming tiny little balls, they form these bigger globs that when they get close enough together, they bump into each other. I could watch this all day long. It's like two black holes colliding when they hit each other. It's fun stuff. Okay. This clearly isn't what a flock of birds looks like. So I need to add some other behavior to make them do something different than this. And I found a reasonable thing to do is to add a target. So I pick one of these birds that all the other birds want to eat. And so I change what the acceleration looks like for that specific bird. And then that will cause the birds to have this balance between wanting to form their flock and wanting to chase this object. So it's like birds eating bugs or something like that. Okay. So to do that, I need to add some more class variables for targets. And I'll set that in my constructor just to be 1 for now. And then I need to define a function where I update the velocity. Oh, they're going together! Oh, how fun. It's like the Borg. They're all one now. Okay, so in update acceleration, I need to define the difference between targets and birds. So I'm going to, instead of looping over all of my birds, I'm going to loop over ones that aren't targets here. And I'm going to define basically a different function to evaluate the accelerations for the target birds and what the target birds do to all the other birds. And so I'll do that at the end of this function. And I'm going to acknowledge that I'm actually going to add more than one target eventually, so I'm going to go ahead and write the code so that it works in that way. Not n target. Do you still want the random nudge now that you have the flocking behavior? You could take it or leave it. we can play around with that once I have everything working, because the behavior will change again dramatically once I add the targets. Great question. Okay, so I have this. Whoops! Oh man, did I just make a new file? I don't even know what that did. I need to add this to my header. Ooh, that's not the header. Okay. Target acceleration. Okay. Sorry, I want to pass in the parameter I as an ID, which means I need to change the call structure. So I'm going to pass in an ID for each target, and I'm going to use the same function to update the acceleration for each target. There's probably a better way to do this. This is how I did. This is how I wrote it the first time. So the function is actually going to look very similar to the update acceleration function. So I'm just going to copy that whole function. D226 GG. I don't want to zero out the accelerations because they've already been zeroed out. I want to define max distance and min distances. I'm not so sure about that. I think I decided that the best thing to do is not have max or min. So any bird can see any target, and any target can see all of the other birds. Otherwise, you could get in a situation like this where a target could be exactly halfway between the bird flocks and nothing would change because they can't see it. So now I want to loop over my targets. No, I don't want to do that. I just want to... Yeah, I don't need the second loop. The target birds must have eagle eyes if they can see all the birds. They do. Just bear with me, because we're not actually going to see the target birds. They're just there to coax out some interesting behavior. So I don't need this loop over I anymore. I just need the loop over J, because I is going to be the ID that I passed into this function. ID is never going to be equal to J because of the way this is written, but sure, I can just leave that check. No, you know what? It's never going to be the same. I'll get rid of the check. I think my acceleration is already 0, so I'm not going to worry about zeroing it out. You know what? Better safe than sorry. Okay. Those are 0. Oh man! Now it's one super flock. But it's like got some weird donut structure. That's awesome. I made quantum birds. It's a DZ orbital. Behold. Alright, that's pretty cool. Okay, so back to this. I've zeroed out my acceleration. I loop over all of my target birds. And then I'm going to use I'm going to use the same minimum image convention that I used before, and now I don't need to worry about I'm going to use a different force function. So the way this is going to work is the farther away a bird is from a target, the less it cares about it. So when they get really close to each other, then they care a lot about each other. So I need some kind of acceleration function that reflects that structure. So I'm going to have, I don't need these if else statements anymore. I still need that unit vector. And then I'm going to use that unit vector times some function that will how do I want this to work? I want it to be the way this is written on my no, that's right. I guess the way I'm writing this, it's going to be the farther away they are, the more that will affect how they move towards each other, which seems backwards, but we can change that. So box size will always be bigger than R, and when, oh no, this is right. When R is very small, this quantity will be big. And when if R was ever equal to box size, then it would be 0. I know that R can never be exactly, R could actually be slightly bigger than box size, but I'm not going to worry about that because I don't care enough right now. So I have these values that involve that unit vector that I defined and also the distance. And then my acceleration for my target will be a sign that I figured out by trial and error, val x, and then I scaled it by this number that looks completely random that I figured out from trial and error what gave me interesting behavior. And then the birds, so this is the target reacting to the birds. Now all the birds need to react to the target. So I have the same thing. Note that the sign is the same, and that's because dx is different from the perspective of the target and the perspective of the target and the bird. So there is a sign change reflected that you can't see, and then that value should be scaled by some completely random number, 0.024 times. This looks really silly, but again, this was me just playing around with numbers, and I have this n here because if you don't scale by the number of birds you have, then the birds would never recognize the target because they'd see way too much information from all the other birds. This is like the coolest. Look at this. How did this happen? Quantum birds. How do I print screen? Screenshot. That's awesome. Okay. Should target birds see other target birds? No, I don't care about that. They could, and that might induce some more interesting behavior. But we won't worry about that just yet. Great question, Rain Lee 323. By some miracle that compiled. Segfault. What have I done? Oh. Well, first of all, this should be J. And then random nudge. I don't need the random nudge anymore. Oh, that's because this is being called recursively. I don't want that either. Okay. Recursive functions. Sometimes good, often bad. Okay, so my birds are flocking, but you see something interesting is happening here. I'm not sure which one. I think that one might be the target that they're all chasing after. How fun is that? Oh no, he saw them again! So when we, and look, there's that quantum bird thing again. Amazing. So to make it easier to tell what's going on, I can change the color of the target. So let's go find where I made my squares. If I is less than n target, then I'll make my color red. And I'll make my square twice as big. Why not? Okay, so there goes my target. He's getting out of dodge. Everyone else is still following. Why is it making this weird donut structure? That's really strange. clearly real birds do not obey the physics that I have coded. Okay, that's fun. In my experience, I have found that more interesting behavior emerges when you have like 2 or 3 birds. So let's see what happens. I must have coded something incorrectly here, because this is not how the behavior that I remember. Oh, there's also a random. I do want a random nudge for my target. So that would be in update target acceleration. And do I want it to be the same size? Sure. Okay. Anyway, with only one target, the flock kind of just follows around. Why does it keep making a donut? Print screen. This is not really the behavior I want. So I'm going to add another target and see what happens. So now with 2 of them, they can't manage to form their original flocks because they're too interested in the birds, in the targets. And I found 3 is the magic number that really keeps them on the cusp of being able to form their sphere structures or their donuts and not being able to do that. And this looks kind of silly, being able to see the targets. So I can always change their size to be 0, so that you don't actually see them. That's pretty good. And like I said, you can change any of the little parameters that I defined and get really different behavior. I'll show you in the target function. If I change how badly they want to see, how badly the target wants to run away, or how badly they want to run toward the target, you get very different results. So if I make the target really scared, then they should retain more of their sphere structure because they can't keep up with the target. Or not. But anyway, you see this looks pretty different from, it's just kind of pulsating. That's fun. Okay, let's try going in the opposite direction. The target can't escape. Yeah, okay, that makes more sense. They end up more clumped together because they can accelerate more rapidly towards the target. Well, I could watch this all day. How many people are actually here? 11 people are watching this. All right. Thanks for stopping by. I actually thought this was going to take me like 3 hours to do. I don't have much more planned. I can play around with different parameters. Anybody have any suggestions? Now I wait 20 seconds for the delay. Does any interesting behavior emerge from constraining the target to half dimensions? Stuck in the middle. That's a great idea. Let's see what happens. So, yeah, so this is exactly, look, before we go on, this is exactly what I didn't want to happen. You mess with these parameters and all of a sudden, it's like Conway's game of life, kind of. It's like there's some stable configurations and others that aren't. So here you collapse into these really ordered structures because the parameters aren't defined enough to aren't defined such that you can break up those flocks, those tight flocks. I find it really interesting that it forms these really strange shapes that I guess fall out from the model. I mean, it must fall out from the model. Okay, let's constrain the target location. So that would be where I update the periodic conditions. So that was using 1 or 2. Donut because of some distance part has symmetry. Yeah, and actually I completely changed the physics of this earlier today. And the old model I had, they would form squares, like cubes. It was very strange. Okay, so that would be, was that, did I write periodic anywhere? I did. Periodic boundary conditions. So I guess I can just do two separate loops here. And I'm guessing if I can find the target somewhere that, so I want it to be less than, oh Lord, this is going to take me a while to figure out. Less than 0.25 times box size. Then I want to, so it's got to be periodic. This is not going to be at all physical, but we'll see what it looks like. Because it's going to be periodic in that. So then if it's greater than 0.75 times box size. And now let's find where I scaled the square size so we can actually see where it goes. Oh, what in the world has happened? They're stuck in the corners. What have I done? So I guess this is either I coded that incorrectly or there's some beautiful symmetry that's where they want to be. I had to have coded this incorrectly. That's awesome though. Let's check back where that was. So if it's greater than 0.75, I make it be 0.25. If it's less than 0.25, I make it be 0.75. So I think that's right. I think they just get stuck in the corners because that's as far away from everything as they can get. And then you get a donut. Print screen! That's awesome. Print screen again. Okay. Great suggestion. It made things look completely crazy is the answer. So I'll just make this back to how it was. Let's see. J. Callahan STEM. You've posted a lot and I haven't said welcome yet, so welcome. Oh, I was just thinking of fixing z to a constant value for the target, like bugs crawling on the ground. Oh, that's also a cool idea. I would guess that would make the birds stick to the ground as well. Let me redo everything I just did. And I'll just set z to be oh Lord, this is not right. I'll just make z equal to the middle of the box. I'm guessing they're all gonna get, we're gonna look at a two-dimensional flock of birds then. That's pretty cool. I wonder if there's any beating in the X and Y directions that we can't see. I guess you would see that with the size of the squares. I can check that by instead fixing, say, X. Some fun patterns. That's cool. It's like when you film a dripping faucet and you can see the rate, the shutter rate in it. Something like that. Now this is really cool. I like this. What else? Anything else, or are we all done? Are you guys bored? I don't know how many people stuck around this whole time, but I want to keep doing this, and I want to do a combination of fun, weird projects like this, and also quantum chemistry projects, because I'm a quantum chemist by training. If anybody has requests for a project they'd like to see, I'm happy to take that into account. The next thing I have planned is a quantum chemistry project, actually. Bird smash! Vestib, how long have you been here? I don't know what that means. Welcome, Vestib, I meant to say. Can you make a max flock size? If more than, say, 10 birds are in a flock, other birds are repelled. That's a great question. I could try that. What happens when they collide? Nothing. So I don't know how long you were here, but there is a force that when they get close to each other, they want to move away. I suppose they could annihilate in a flash of light. You know what? We should have done this whole thing. Birds on a string. This is awesome. The problem with the max flock size is, I think it would be, I don't know what, I guess I could just assign every bird as having the maximum velocity whenever there's so many birds close to them. I don't know. That would take me a really long time to figure out how to do correctly. Okay, what if you just do it for the target bird? Can you elaborate? I hate the delay. I feel like I'm on the space station or something. Or Mars. All right, I'm bleeding viewers. This was fun. I think I'm going to do this again. Okay. If no one else, sorry, Blue Density, you asked things that I can't do quickly. But good suggestions. All right, I guess I'm going to sign off if no one else has any other suggestions. This is really cool, though. What if you confine it to only one dimension? I'm going to try that first. That's probably going to look really dumb. What's my next project idea? So for fun projects, I have done some other OpenGL stuff. I wrote a little Frogger game once. And I also wrote a Rubik's Cube solver with it visualized. I can actually pull that up if you want to see that. It's not in Supercoding Fun Times repository yet. Oh, there it is. So the cool thing here is I can try to solve it, but it's the worst rendering thing ever. So I want to put the white dot at the top. Oh, there it's at the top. And I actually have, there's a mode where it will solve itself, but I'm guessing it will solve itself before it even pops up on the screen, because it's just too good. That was a joke. So it solves itself. Oh, you can see it printing out. It knows what it's done. It solved each corner, blah, blah, blah. Oh, it's being solved more than once, and everything went insane. And then I have a Sudoku solver and a web interface for that. So these are all much more involved projects. The Frogger one I could probably do in 3 hours. The Rubik's Cube one and the Sudoku one might take a little longer. And then there's also these things called, I don't know if you're familiar with Project Euler. That's really simple programming projects. Some of them are very complicated, but they start out really simple. You have to count every prime number under 1 billion or something like that. And so you learn tricks for generating prime numbers that way. So there's some really interesting Project Euler problems that would be fun to do in this kind of environment. The Sudoku solver I wrote is actually from that. And then at around Christmas time, there's something called Advent of Code, where it's very similar to Project Euler, but a new project comes out every day. And it's insane. The people who finish it the most quickly finish in 4 minutes, and it takes me 12 hours to do one of them. I have no idea how they do it that quickly. No idea. And then in terms, I don't know if you're a quantum chemist or if you're just a fun person who decided to show up, but my group does something called couple cluster theory, and it's a very complicated quantum chemical method, and it's useful to have computers generate the equations for you because it's very error prone to generate them by hand. And so I have most of a code generator written, and so I was going to sit down and fix some parts of it to make it more flexible as one of these. There's also simple methods to generate wave functions for quantum mechanical systems. There's one called Hartree-Fock theory, so we could write a Hartree-Fock program here. You do quantum! Okay, yeah, so we could do, I have a whole bunch of quantum tutorials on my website, and we could do things like that. I had been thinking about, I do most of my coding in a program called Sci4, because I think it's really easy to develop code there. And so if you did something like second-order perturbation theory, there's probably 3 or 4 different ways you could implement it in Sci4. You could do it in Python, you could do it in C++, you could do it with conventional electron repulsion integrals, you could do it with density fitting, a lot of different options. So I have a really simple MP2 perturbation theory tutorial on my website that I would like to make a video form of. A lot of this is also to train my group in the future. I figured that if they had real walkthroughs for different things that we do, it might help them out. And that also would involve things that are outside of quantum, like linking to math libraries and how to use fancy math libraries to do matrix multiplications quickly. I think the next thing I do will be the couple cluster related project, maybe next week. Okay. Well, I still think birds on a string. I should have called this birds on a string. I should have known that you could do birds on a string. Mario 1 speedrun. Okay, I can do one. It'll take me a second to get the timer set up because I don't have, because this is Linux and everything is hard in Linux. I can't believe this hasn't crashed. That's not right. Cancel. So Ken, I'm sorry. So, dang it. You can't see what I'm doing, so I just sound like a crazy person. Vestib, this is the basic timer I have. You probably saw it before. So I just cover up the parts that aren't the numbers. And the problem is, with the driver I have, the video card driver I have, I can't add this to OBS as like a window capture. It doesn't show up. And that problem happened whenever I upgraded my video driver. So I have to do this janky way where I have a different screen for games and I cover up the number. Whoops, sorry. 2 screens is hard. And I cover up the numbers. There we go. Mario 1 speedrun. If you're not interested in Mario, sorry. And Vestib, if the audio is all messed up, let me fix this so that I can check this in. So this code I'll put in Supercoding Funtime, the repository. Can you change the color of the background and everything but the main timer? What? I'm not sure I know what you mean. I can get rid of almost everything, all of the word there. We can play around with this when we're in person. Yeah, that's a good point. That's a really good point. Good idea. Okay, let me fix this so that it can go on the repository. Exit. Now, Mario time. I'm not sure where... Vestib, say something in the chat because I'm not sure where the chat shows up on the screen. Or you were already talking, so I do know that. I think I must have moved it after you commented earlier. Okay. Let's do this. I like Mario Brothers. I have like a top 400 time in Super Mario Brothers, which is not very good, but it's pretty good. This is not going to be a top 500 time. Test. What does test mean? Oh, it's not. Why isn't it showing up? Twitch chat. Try again. Ken, can you try again? Vestib. Test. Okay, good enough. Okay, and now I couldn't get the foot pedal you let me borrow working, so I have to use the spacebar. Spacebar, here we go. Oh, I started early. What am I ranked? I'm not actually sure anymore. It has to be, I don't think I'm top 400. I think that was a perfect 380, but clearly it wasn't. How's the audio? I don't have it on for me, so I have no idea how loud it is. That is crazy. You need to get back into it, man. That's crazy. I must be way higher than... I wonder if I'm even top 500 anymore. Reset. How do I change my status to playing Mario? Whatever, it doesn't matter. I can't figure out. Okay. Yes! I honestly can't believe that sub 5 only gets you 203rd. Wow, that's crazy. That's really insane. Can you get sub 200 with 6 fireworks? The answer is no. Can you check mine, Ken? I think I like electrons. Worth a try. Oh, that's really good. I still can't believe I finished that project in an hour and a half. I honestly thought that it was going to be like 3 hours and no one would be left watching. Beautiful. Almost got that 336. 478! Oh man. That's not good. Ugh. Oh, come on. Are you watching chat on Twitch or in OBS? On Twitch, both. OBS was, no, sorry. Twitch on my Ubuntu machine was making OBS really, it was making everything slow, so I have it open on my laptop, but it's kind of hard. It's like nowhere near what I want to be looking at, so it's kind of hard. So mostly in Twitch, but sometimes I only notice out of the corner of my eye in OBS. So I guess that's a reason to keep it in OBS. Woo! Oh, super good. Stupid fireworks. There is a large delay between Twitch chat and when it shows on the screen. Yeah, I guess it's the same, whatever, the 20-second delay or whatever is set up. I need to think about those types of things. Oh my god. 12 seconds. Alright, I'm just playing to beat this now. No world record. Ken, this is probably cringeworthy for you. Oh gosh! I'm not very good at this level. Woo! Six people stuck around. Thank you, everybody. You haven't played... Ken has not played in a year. I have played, like... I hadn't played in a really long time, and then I set up this setup for teaching and like installed however you pronounce the name of this software. And I played a lot that 2 days. One more time. I played a lot that 2 days around then, but not really since then. Not enough so that I can time when to start the timer. I really wish I could figure out how to use the foot pedal in Ubuntu, but I have like literally no idea. I can't find the right drivers. But I guess it's not so bad having to hit the keyboard with my pinky. Hey everybody, Vestib has runs another channel called Ask a Scientist, where he has on scientists, mostly from FSU, Florida State, where we're both professors, and you guys should all follow that channel and watch Ask a Scientist. It's awesome. It's a great place to learn about science or about graduate school and what goes on. They play video games there. Okay. One more time. For real this time. Go away. That was awesome. Hey Vestib, is that you showing me that you're in the top 10 in Dr. Mario? I guess I can click on it. Oh, it's levels 0 through 10. Oh, what place would you be once you post it? Go down the hole. 50, that's not bad. What's the lowest ranked one? Have only 51 people put in scores? I haven't tried that challenge, so I don't know. I assume 17 minutes is awesome, but I haven't tried it seriously. This is basically the only game I ever play. And I'm still not very good at it. 48-17. Oh, I could beat that. Okay, my new goal is going to be top 100 time in Dr. Mario for levels 0 through 10. Ah. Perfect. Alright. Wrong warp. Perfect. Everything's great. That was awesome. Okay. You know, I thought I was doing an okay job monitoring the chat while I was programming, but this is like completely impossible. Not that anyone's chatting. I wouldn't know. 2531. I don't know. I guess I could do that. I have no idea. My problem with Dr. Mario is I only know how to... I'm like Khan. I'm very two-dimensional. I guess I'm one-dimensional. I think one-dimensionally. I guess that's the key. All right, 6. That's great. I think regardless of what happens, I'm signing off at 10 o'clock. So everybody, hold on to your hats for the last 4 minutes. Alright, this is gonna be good. Here we go. Should I include this part of the video in my tutorial for making birds on my website? Yes, I think I should. Given my channel topic, what now? I should explain the wrong warp. Ah, okay. So the wrong warp, which was where I went down a pipe earlier and ended up upstairs in the mushroom land, is related to a glitch where at any screen, there's only one next location loaded. So if you can trick the computer into thinking trick the game into thinking you're at the spot where, I will do one here. I didn't do one. Anyway, you can trick the game into, I'll do one more. And the red color means it's slower than my best time, which is 5:13. You can trick the game into thinking that you're in a position where the next room is different than where it actually should be. So you go down a pipe and it thinks you went up a vine, that kind of thing. I know that's not a particularly good explanation of the wrong warp, but that's how it works. So if I get back to that point again, I will explain it again. For real, this is the last one. Everybody, it's on the internet. I got a 380. Oh, so good. .3 seconds behind the world record. 0.4, 0.5, 0.6 seconds behind the world record. The only way to do that first level faster is to do something called a flagpole glitch, which is where you land at I have no idea how you do it, but you land at a certain spot at the base of the flagpole and hit a certain combination of keys, and the flag doesn't come down, and that saves you 0.3 of a second. I can't do that. That's beyond my skill set. That's beyond the amount of free time I have. How about that? Although I have enough time to get all these extra coins. Okay, so I could potentially do that wrong warp again. So I'm going to jump. What I want to do is advance my X position enough so that it thinks I'm in a different part of the level than I'm actually in. And you can do that by jumping backwards into blocks. So you'll see me jump backwards into blocks a few times. Jump backwards, that's one. I might have done it enough, but I'm going to try a couple more spots. I missed that one. And then that one, I jumped backwards. So now it thinks I'm farther along than I actually am, and instead of going down the pipe, I end up upstairs where I should have been if I climbed the vine. Whoops. And that's much faster than climbing the vine, because Mario is slow when he climbs. But Stib, how much faster is that, do you know? Off the top of your head? Oh, about a second faster. How much time do I lose by beating half of 8-1 and then dying? Probably more than a second. Probably about 30 seconds. I think this is definitely the longest level in the game, right? Vistib, I noticed in your stream, your Mario is bigger than mine, but this is the maximum size I can make mine, which is kind of annoying. Oh, here comes the bullet glitch. Who's ready for it? Not only did I not get the bullet glitch, resize in OBS. Oh, you're such a smart person. Do I want to do that now? No. Actually, the problem is, it's just on the... I guess I can resize the whole screen? Yeah, that would work. Alright, I got 1 life left. I don't have time. I keep wanting to try to do it. I don't have time. Oh! I did not see that coming. Okay, I'm going to do another wrong warp here. I'm going to run a little bit past this pipe and then go back, and it's going to think I'm at the next pipe. Oh, that was no good. Alright, last screen. Nothing I can do about that. Okay. Alright, that's enough Mario for me. Thanks everybody who stuck it out with me for 2 hours. That was fun. I'll probably do this again on the order of once a week. Depending on how much random, like research-related programming I have to do, I might log on and just do some coding related to my research. Who knows if anyone will want to watch that. Okay, anyway, give me a follow if you didn't already, and I'll see everybody next time.